In Chapter 7, we're going to be discussing protein. So what are proteins? They are organic molecules composed of carbon, hydrogen, and oxygen, and they also contain nitrogen. The human body contains an estimated 200,000 different proteins. Table 7.1 talks about the functions of proteins. It helps with the structure of hair and nails, new cells, enzymes, lubricants, clotting compounds, antibodies, and it's an energy source. So proteins do a lot in the body. There are specific type of proteins. Structural proteins such as collagen, contractile proteins that allow muscles to move, and structural proteins such as keratin found in hair, skin, and nails. One thing about proteins is they help to maintain the proper distribution of fluid within the bloodstream and body tissues. So when there's not a fluid balance, then you can end up developing edema or swelling, as you can see in the photo of a normal tissue as opposed to one that is swollen in the foot and ankle. Protein helps maintain the acid-base balance, so that helps to maintain the proper pH of fluids. Fluid and tissue, blood and tissue must maintain a pH of about 7.35 to 7.45. If it's acidic, it has an excess of hydrogens. If it's alkaline, it does not have enough hydrogen. Proteins act as buffers and they accept or release hydrogen. So one thing we know about proteins is they're made up of smaller units called amino acids, and there's 20 different amino acids in human proteins. Some of them are essential and some of them are non-essential. Essential cannot be made by the body. They have to be supplied by the diet, and they consist of 9 of the 20. And the 9 non-essential can be made by the body, and they are 11 of the 20 amino acids. Table 7.2 goes through all of the amino acids from essential to non-essential. So rather than reading that whole list, you need to just look at them and become familiar with. You don't have to know every one of them, but get an idea of a couple of the essential versus non-essential amino acids. Nearly all the foods contain some protein, and animal foods have more protein than plant foods. Legumes, plants that produce pods with a single row of seeds. Examples are peas, lentils, peanuts, soybeans, beans. These are another form of protein. A high-quality protein is called a complete protein, which means it has all of the 9 essential amino acids. Most animal products will have that. There are some high-quality plant foods, such as quinoa, that also has a complete protein. Low-quality or incomplete protein does not have all of the essential amino acids, and you'll find that in plant foods. With amino acids from proteins, each distinctive bead represents a different amino acid. The hook connects the beads and represents a peptide bond. Protein digestion begins in the stomach. Hydrochloric acid breaks down proteins. Pepsin digests the proteins into smaller polypeptides, and they enter the small intestine and they get broken down into the individual amino acids. One key point is that although protein begins to digest in the stomach, the absorption occurs in the small intestine. Deamination is a removal of nitrogen from an unneeded amino acid, and ammonia is converted to urea that the kidneys end up excreting in urine. Nitrogen balance or equilibrium means that there are not too much nitrogen and not too little. So positive nitrogen balance, the body retains more nitrogen than it has, and negative, it loses more nitrogen than it retains. So if we look at the photo, the scales, you can see the difference between positive nitrogen balance, nitrogen equilibrium, and negative nitrogen balance. So with a positive nitrogen balance, that occurs when you're during the growth stage, pregnancy stage, when you're recovering from an illness, or when you're doing resistance training. Nitrogen equilibrium, that means you're meeting your protein and energy needs, and it's a healthy adult that is in equilibrium. Negative nitrogen balance, you don't have enough protein, or the digestive tract cannot absorb it. You have increased protein losses resulting from kidney diseases, blood loss, if you're in bed too long, have fever or injury, or if you have a secretion of the thyroid hormone or cortisol, the stress hormone. How much protein do we need? About 0.8 grams per kilogram of body weight. That need will increase if you're growing like a child that's during the growth stages, pregnancy, lactation, and if you're recovering from illness or injury. The formula you can use, you can take your weight, divide it by 2.2 to find your body weight in kilograms, multiply it by 0.8. In this example, it's a 165-pound person divided by 2.2 is 75 kilograms, multiplied by 0.8 is 60 grams of protein the person needs per day. Typically, about 15% of the typical American's diet was consisted of protein. It's suggested that we have somewhere between 10 and 35%. MyPlate has dietary guidelines for protein intake. You want to make sure you're choosing lean or low-fat meat and poultry. So lean cuts of beef include top round, sirloin, pork, tenderloin, centerloin. You want extra lean ground beef, at least 90% lean. And if there are some, places where there's fat on the meat, you should trim it. So that's it for part 1 of proteins. We will continue in the next video in part 2 of the chapter.